Green screen fails. Of course not. It knows.
There. There's no audio for me, but now it's there. Yeah, so as people can tell, there's no green screen, or there is a green screen behind Pamela. So instead of that really cool starscape, but I gotta show people this. So your green screen goes for any color but green.
Yeah, I can get it to do my hair. I can get it to do my, let's click again. I can get it to do my skin. I can't get it to
Just
do
these
the
eyes.
green.
Oh man, that's incredible. I love it.
Yeah, so I don't quite know what's wrong with it. It was working perfectly when I first turned on the software, and then it lost its mind.
Yeah.
So the green is needed in the window because otherwise I'm way too backlit.
Yeah.
Which is why I was green screening it. I just put green foam in the window. But I got noped. I got noped hard.
So it's weird. My YouTube's thing is telling me that my audio stream bit rate is lower than recommended. I wonder, I've never seen that before.
That's a new form.
So I'm doing a sample rate is 44.1 kilohertz, but it says I could also do 48 kilohertz.
But 44.1 is standard.
Yeah. Although I did a stream with the Skeptics Guide, and they said 48, it's got to be 48. Let me see what the audio bitrate is. The audio bitrate says it's 160, and it's asking for 128. And isn't 160 a bigger number than 128?
Yes.
Yeah, I feel like that's a true thing that I say. Oh well, whatever. Just, it's fine now. Excellent connection. It's all good. Yeah, so people have to tell us, yeah, which of these they're calling it the star being. So that's your new that's the new you.
It's not a new me I enjoy necessarily.
I'm sorry, but I have to put my foot down, speak for our audience, and say, it's a perfectly, yeah, that's so great. Look at you, you're just lost in space. You are space. You're the embodiment of stardust.
I don't mind being space.
You just got spaced.
I prefer it when it's my hair instead
That's pretty
of my
cool too,
face,
actually.
however.
Yeah, that's awesome. That could just be your default from here on out.
It means I wouldn't have to dye my hair anymore, but
or if you ever wanted to go out in public, you would have a more complicated dye job ahead of you to keep things standard. Yeah, I do. I think I like the hair version better than the skin version, but it's still a pretty incredible effect either way.
Yeah,
all right, well, let's make an episode of Astronomy Cast. So for
Okay.
people who are wondering what it is that they have stumbled into, this is us. This is what happens before and after we record our episodes of Astronomy Cast. Oh, I should say hi to some people. I'm going to say hi to Adam Synergy, Andy Cowley, Eris Ekavaria, Beth Johnson, Bill Sugden, Bruce Bushy, Capital H, Shay K. Oh, that's cool. Christian Barrett, Daniel Yunt, David McFadden, DPI 209, Dustin Haskins, Dusty Reichwin, Giselle Sabarin, Gordon Dewis, Grant W, Guido Bibra, Harry M, Jamie Ellenarch, Janelle Duncan, Jason Elric, John Seffel, Johnny J, Johnny Z, Kylie Cerna, Martin Bradshaw, Mrs. Nat, M. Till Ford, Paranor, Paul Gracie, man, everybody's here. Rami Imad, Rich Wilson, Rich 901, Scott Bragdon, Sergusi, Slam RN, Stein Folaras, Stephen McGinnis, Tejutuan Tuju, Trent O, and Zapvan Zapvan. All right, hey everybody. Yeah. So anyway, all right, and hi to everybody at Twitch. I'm sorry I don't see your Twitch names, but we are thinking about you as well. So before we get on to this week's episode and actually start the recording, just a couple of pieces are in order. One, we have a new episode of the Guide to Space, of course, but it's not going to be premiered immediately after this episode because it is still it ended up being a little more complicated than we anticipated. So it's a gigantic episode. It's like a double-length episode all about the Artemis program and the lander configurations and so on. So, but a couple of hours, I would say by 4 o'clock. So,
And how long do you think it will be before it's completely deprecated?
our episode?
Yes.
Well, the key is that I sort of essentially defined every possible option that's being considered right now. So
you cheated.
Yeah, so in the end what'll happen is, and I said it could happen in 2024 or it could happen in 2028, and it could be one launch, it could be 3 launches. So all the different configurations. So I tried to future-proof the episode. And we're actually apparently going to hear the NASA's announcement on who has won the contracts for their for the landing systems, probably within the next couple of weeks. And the cool thing is that they're almost certainly going to go with the same system that they did with SpaceX and Boeing. So it's going to be they're going to alternate. So it's going to be one landing stack from one team of providers and then a different landing stack from a different team of providers, and they're just going to alternate back and forth. And I really think, we did talk about this last week, but that, a certain new SpaceX employee did a fantastic job of building a very redundant and resilient system for returning humans to the International Space Station. I mean, here we are. SpaceX has had its problems. Boeing's had its problems, and yet SpaceX has worked through theirs more quickly, and now it looks like they're going to launch in like a month. So.
Yeah. It's awesome.
Yeah, absolutely incredible. And so it feels like that's the right way to go. And so we'll see something similar happen with the lunar landers, which is totally different. And I think it's great. The second thing is I'm not going to be here next Friday or the Friday after that. So I'm going to be in Japan with Logan.
Spring break,
y'all. So Logan and I are going to be flying to Japan on Thursday. And then we'll be there until the 7th, and then we fly back.
And then you get quarantined for 14 days?
And then I get quarantined for 14 days. Yeah, exactly. We're not going to visit any cruise ships that happen to be docked in Yokohama. That we've taken that off the itinerary. But the World Health Organization today is saying, meh, don't worry about it. We are going to take some hand sanitizer, and we'll take some masks just to be safe if we go somewhere that's, seems like it's appropriate. And apparently
crowded.
Masks are in fashion in Japan. So, you always see people wearing face masks walking around on the streets.
One of the things I love is they recognize that being healthy is more important than looking good.
Yeah.
And so, like, if there's a high pollen count, anyone who has pollen allergies will wear a mask so their allergies don't get angered as much. I have so much respect for that.
Yeah, that's a perfectly reasonable explanation and a reason to wear a mask like that. So anyway. And ideally, I really want to try and go to JAXA, and especially because we just saw yesterday the announcement of their new Phobos mission. So that would be amazing if I can make that happen. Although this is not about me. This is a trip for Logan. This is his dream trip, and I'm just, you know, I'm just his wingman. So
I'm still saying stock up and be prepared for the irrational quarantine
yes,
that is destined to happen on your return home.
got it. Yeah, I'm ready. And I'll buy some masks here in Canada before we go, where they're not in as high demand as they are over in Japan. Um, and then the other thing that I just wanted to do was give a big congratulations to Dr. Ian O'Neill, who
Yes.
just announced that he is joining NASA's Jet Propulsion Lab in their media relations group. So Ian is going to be the person that we talk to at NASA when we're finding out news about a lot of missions that are coming out of JPL.
It's coming full circle.
It really is. It really is. I mean, Ian has been just a great uh, writer and journalist and science educator for more than 10 years now.
Oh, yeah.
One of my favorite, like someone who has always felt has like one of the best eyes for news, has a really good judgment and sense for how to put stories together and what
Yeah.
things are really going to resonate with the public. And to see him actually working with NASA is fantastic. So congratulations, Ian. I couldn't be happier than hearing this news, and I look forward to all of the new stuff that you want to announce. We'll definitely be reporting on it. All right, so let's get rolling on our episode about Betelgeuse.
What's the episode number?
It's 560.
This is me recognizing, oh, crud, it's going to ask me this question 30 seconds before you ask, are you ready? And the answer is, I'm now recording.
You're recording.
I am.
I hadn't
jumped the
even
gun.
started up Audacity, but now I'm already recording.
Okay.
Yeah, it was too quick.
We're sorry, Susie.
That's okay. Now it's all ready to go. Okay. What do I do here? Oh yeah, right. We record Astronomy Cast. Okay. Here we go. Astronomy Cast, episode 560. Betelgeuse. Welcome to
Betelgeuse.
Astronomy Cast.
Betelgeuse.
Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain, publisher of Universe Today. With me, as always, is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I am doing well. How are you doing, Fraser?
I'm doing great, and I mentioned this in the preamble, but I just wanted to say this again, which is a huge congratulations to our good friend Dr. Ian O'Neill, who just announced that he's going to be working at NASA Jet Propulsion Lab in their media department. Ian is a terrific science journalist, one of the best in the business, and it's a pretty good fit that he's now working over at NASA. He was the editor for the Astronomical Society of the Pacific's Mercury. He has been a columnist for Discovery and Seeker. He did some work with us at Universe Today, and this is great. So congratulations, Ian.
And we're going to take the next 2 weeks off. I'm going to call it spring break.
Yes.
I'm not going anywhere. I'm just going to be writing software, but you, sir, are going on a grand adventure.
Yeah, I'm going to Japan with my son, and this is not work. This is literally just him. I said, "Where do you want to go?" And he goes, "I want to go to Japan." And then I waited for cheap tickets to come around, and they did, and so we're off to Japan. Of course, we're off to Japan when there's a coronavirus, but we'll take precautions, and it doesn't look like it's that bad there currently. So, and I can't wait to see this place. I've wanted to go to Japan all my life, and to be able to do this is going to be a lot of fun. So I'll definitely take pictures. Might visit a few spacey things like the Japanese Space Agency, but this is about his trip, not my trip. All right, well, so you might be surprised to hear that we've never done an episode of Astronomy Cast featuring Betelgeuse. Well, good news. This is that episode. So let's talk about the star, why it might be dimming, and what could happen if it explodes as a supernova. I had to do a search before I actually you know, wrote up my intro, and I think we suggested this one to for Susie to put on the calendar. And like all of this time, we've talked about Orion, we've talked about the way stars die, and we've obviously mentioned Betelgeuse many times as a candidate for a new supernova, but had never actually spent a whole episode on this one specific star. Well, obviously good timing on our part, because it's so interesting right now. So what is Betelgeuse?
It is a red supergiant star that is visible to both the northern and southern hemisphere. We have no hemispheric bias in choosing this star. It has evolved off the main sequence, which means it is no longer burning hydrogen in its very core. And it probably did this only about 1 million years ago. And now it is systematically burning through heavier and heavier shells of elements deep in its, well, many, many solar mass self as it hangs out shining bright in the northern winter and the southern summer.
And it is Orion's right shoulder. I mean, when you look at it, it looks like it's on the left, but if you were Orion and you were facing towards us, then it would be his right shoulder.
And there's some fascinating history on its name. And I have to admit, I went down a little bit of a rabbit hole prepping for this episode. Its name is Arabic,
Yes.
and over the years has uh, probably been mistranscribed, so that there are those that believe that it translates as Orion's armpit.
Right.
And this can be caused by just dropping a little dot under one of the characters at the wrong moment in time. It probably has a much better name than Orion's armpit. This is still up for a fair amount of discussion.
Well, actually, so one of our viewers, Rami Ahmed, who speaks Arabic, he's saying that it is the name comes from the Arabic Ibit el Jawza, which literally means the armpit of the mighty hunter. So that sounds better than Orion's armpit, which is armpit of the mighty hunter.
It's true.
Yeah.
It's true.
And we are going to mispronounce it. And of course, the hilarious thing is how people give us such a hard time because they're expecting that it should be Betelgeuse.
Yes.
And we tend to say Betelgeuse, and that's a little bit of a holdover from, I think, the way they used to describe it before the movie came out, and the movie sort of has shifted it to Beetle. But even that isn't correct. So maybe we can, after the fact, maybe get Susie to get maybe Rami or someone to do the proper Arabic pronunciation in the show, and then, so that then that can serve as sort of the standby. But
yeah.
and I've heard a lot of people, like even like Germans say, say that, well, actually it's a German word, but it's not. It's an Arabic.
No.
It
Yes.
comes from, it has an Arabic root. So anyway,
And yeah.
so we're going to say Betelgeuse, and maybe even shift to Betelgeuse every now and then. Please just bear with us.
And however you choose to pronounce it, this isn't an object that was strictly noted and observed by people living around the Mediterranean Ocean. This is an object that it's variable in its brightness, as all of us can currently go out and see. And this variability appears to have first been noted by the Aborigines of Australia. It is a star that crops up in the lore of society after society. But the science, the awesome sauce science, is why we're here today. Because when you ask which objects in the sky are most likely to go boom, this is one of the two. Eta Carinae is the other. It is strictly Southern Hemisphere. So, really, Betelgeuse is the one we want so that all of us can enjoy the experience. And the problem is, we don't know when this is going to occur, but scientifically, we're pretty sure it's not now.
Right.
But you can hope to be wrong.
Yes, yeah. So it's a random event, and we'll talk about this a little bit about what's going on and how we might know. But so I just want to talk a bit about just what stage it is, what kind of star it is compared to, say, a star like our sun. So how does this star compare to our sun?
I radically different. Our sun is because it is ours, it is used as the measuring stick by which we measure everything
Right. It
else.
weighs one the sun. Yeah,
Exactly.
it weighs exactly one the sun.
Betelgeuse is estimated that when it was in the same evolutionary stage as our sun, when it was on the main sequence, burning hydrogen in its core, it's estimated to have been just under 20 solar masses. If we had seen it during that stage, it would have been one of those bright blue O type stars like we love to enjoy in the Orion Nebula. Orion is a massive star forming region. That entire swath of the sky is rich in all the things needed to make stars. And there's lots of young stars in that direction. Well, Betelgeuse isn't necessarily young. It finished burning all of that hydrogen, but because it's so massive, as it evolved off of the main sequence, as it expanded out, it didn't go through this massive flash that we see in smaller stars where it suddenly was like, boom, I'm going to burn helium in my core. Instead, because it was so massive, it was able to gradually transition into doing this. And as it did, it just basically migrated sideways across the color magnitude diagram, that Hertzsprung-Russell diagram, ending up in the top center of that diagram being cool, red, and kind of unable to hold on to all of its atmosphere.
Yeah. And you know, you say that it's kind of, it's not young anymore, but compared to the age of our sun, it's super
Oh,
young,
yeah.
right? It's a baby. It's
Yeah.
only,
So
it's already old. Anyway, it has a very short life.
it it uh it was only on the main sequence for millions of years, unlike the billions of years that our own sun will spend there. About a million years ago, it ran out of that hydrogen. And this is where we start asking, okay, so when did it really settle in to being this nice, glorious supergiant that we see now, this red supergiant? And the red supergiant is linked to, okay, we have burning going on the inside, we've had a dredge up of materials, and we think that all of these things have only been going on for tens of thousands of
Wow.
years. And when you start being able to consider that humanity has been around longer than the given phase of a star that we're observing, you recognize how short a period of
Yeah.
time this
And
is.
possibly even like agriculture has been around, right? Agriculture
Yes.
has been around for longer, possibly, than Betelgeuse has been in this red giant phase. So let's talk just like what's going on. Now you mentioned that it is burning. Obviously, it is not like burning wood and coal in the
Right.
core. But what is happening to the star right now, and causing it to do some of the weird stuff that it does?
So we can't know exactly what layers it's burning at any given moment. These stars like to hide what's going on in their heart. Uh, what we know is while it is this red supergiant, it is going to start out burning helium in its very core with a shell of hydrogen around that. It is then going to transition as it burns that helium into heavier elements. It's going to transition to burning carbon, nitrogen, eventually silicon, until eventually it ends up with an iron core. And it's at this point that the star goes kaboom.
Right.
And during this process, it's giving off massive amounts of light. What this means is it has a massive light pressure pushing outwards. And that's what is able to support this star that is bigger in radius than Jupiter's orbit.
That's crazy.
Doesn't reach all the way to Saturn,
Right.
but it's trying.
Yeah, but it would gobble up Jupiter. Yeah.
Oh, yeah.
But it varies. And so, I mean, it is a variable star, and part of the variation comes from literally the change of the star's size.
Yes.
So it's not always the size that it is right now, and it changes quickly.
And it changes all the way down to, we think, roughly asteroid belt sized orbit.
So like tens of
tell.
millions of kilometers, possibly like 100 million kilometers across its radius, is getting bigger and smaller.
And it's really hard to nail this down. And one of the reasons it's so hard to nail this down is, how do you define the edge of a cloud?
Right.
This star, at its outermost layer, light pressure is greater than gravitational pull sometimes. And this means it's pushing its material away. And this outflow is building clouds around it. And this is part of what makes it so hard to figure out the real age and evolutionary stage of the star, actually, because in an ideal situation, we'd look at it, and sure, you can't measure its diameter, you can't really tell exactly how much mass it is lost, but you can get a pretty darn good estimate by measuring how much mass is around the star. But Betelgeuse is what we call a runaway star. Due to something bad that happened in its past, it is flying through space at a fairly high velocity, and it's losing mass as it goes. And because it's losing mass as it goes, it's literally leaving its mass behind.
Right. Like a cometary trail.
And so we can't figure out how much mass it's lost because we don't know where it left it.
Right. Right, because it's been moving for hundreds of thousands, millions of years. Now, let's pretend like it will die soon. What will happen and what will remain?
Well, we don't know all the details of what stars do before they go boom. If we did, these radical dimming events that we're going to talk more about.
Yes, yeah, we'll get to the dimming. Don't worry.
Would be less exciting. What we think is the star will essentially run out of the ability to keep producing energy.
Like it just runs out of fuel the fuel that it was using in the core.
And so all that light pressure that was pushing out, it's going to stop being produced. Now, light takes a long time to exit a star. And so it's going to be a gradual coming in on itself. It's going to accelerate and accelerate until all of a sudden the infalling material, which is heating up as it goes, is going to stop just generating enough pressure to maybe hold the star together a little bit better. And it's instead going to start hitting the pressures and the accelerating inward, driving more pressure, that is going to cause a supernova. Now, this object we suspect, this star we suspect, will be order of 15 solar masses when it goes boom.
Mm-hmm.
Order of, again, we don't know where it left all its mass. And that means it's going to leave behind most likely a neutron star.
Right.
So we're going to have a classic supernova event, neutron star left behind. Think Crab Nebula, but way closer.
Right.
In my head, the way I think about this is someday in the future, when they're teaching about the constellations in the mythology, they can upgrade the story so that Orion has a bloody shoulder from where Taurus gouged him or something.
Yeah. I mean, imagine and it probably would be visible with the unaided eye, like
Oh
not
yeah.
the explosion. Like the explosion would be absolutely visible and
Yes.
possibly and definitely visible in the daytime and possibly even brighter than the full moon. I've heard
Yes.
estimates. So it'll be ridiculous. But even after it's done and gone, the remnant will probably be bright enough to just see with your eyes just there in the sky. That it'll be
Yeah.
about the size. I mean, when you think about, say, the Crab Nebula after 1,000 years ish, is is a teeny tiny blotch in a fairly big telescope. Like I'm imagining something that is like the size of a full moon in the sky, that is this big red blasted smear in the sky where there used to be a
And
star.
the Crab Nebula is more than 10 times further
Yeah,
away.
yeah. So 10 times closer, bigger than the Crab
Means
Nebula.
100 times brighter.
Yes, thanks
And so
to the
we're going to
lumin.
have something that's 100 times brighter. Now, it's also going to be spread out over a larger area on the sky. So it's not that every arc second is going to be 100 times brighter, because you have to deal with the fact that the light's spread over a larger area, but there's more of that light getting to us. And this is a calculation I need to do. I meant to do it in time for the show, but day job got in the way. Um, Stay tuned. This is something I'm probably going to do for fun on
Yeah.
my blog at some point. But yes, we're going to have something bigger in the sky that we're going to be able to see by eyeball.
Mm-hmm.
It's just a matter of how long are we going to be able to see it before it gets so big that its light spread out too
Right.
much.
Well, and we do have examples of that. There's like the Veil Nebula, the whole Cygnus supernova complex is this gigantic supernova remnant that is a huge portion of the sky. You need to take multiple images in a telescope to be able to see it. And that's an example of one that exploded a long time ago, and we're just seeing the wreckage just expand outward into space. So imagine if it was a lot more compact and a lot closer and a lot brighter. So yes, yes, please. Okay, so let's shift now to the sort of the recent excitement, the reason why Betelgeuse has come across everybody's news feed and why everybody is so excited that maybe this time it'll explode for real. So why? So explain the dimming. What's going on?
Well, we don't know exactly what's going on, but I can tell you what we
Yeah,
observed.
tell me what we observe.
So normally Betelgeuse varies in brightness by a couple of magnitudes, worst case. And this brightening and dimming has a multi-year periodicity to it, and it also has a hundreds of days periodicity to it. So you have all these complex, just how bright does it get, how faint does it get at any given period, is a combination of both of these semi-regular, sometimes forget that they're actually supposed to do something, variations. This is what's called a semi-regular pulsating star. It's not entirely understood why these stars pulsate, because really it's like a cloud in the parts of the star that's undergoing these pulsations. And so this super diffuse material is changing how big the star is, which is changing how much surface area is giving off light, which is changing the luminosity of the star. As it changes in size, it's also changing in temperature. Fine. We've been observing this for hundreds of years, no big deal. But for reasons no one can yet explain, but we're trying to get all the possible observational data to eventually be able to explain it. Betelgeuse dropped down to 35% of its normal luminosity. Now, I'm not saying it was 35% off. I'm saying it was 35%
Of
of its normal brightness, 65% off.
right, right. That's a sale. I could
That
buy. I'll
is
buy
one
two of
heck.
them and
Yes,
save one for a
please.
rainy day.
So this means that folks going outside looking at Betelgeuse, who are used to seeing this amazing bright red star as one of their wayfinders in the night, and this includes me here, is going outside and suddenly is like, wait, where's Orion? Can't find it. Because that thing you look for suddenly was the same apparent magnitude as the other shoulder.
Yeah. Yawn.
And yeah, it
Yeah.
starts masquerading as like the top two heads of Gemini or something. And you need to find the whole constellation
Right.
before you can make sense of it.
Yeah. So before the dimming, it was regularly the 11th brightest star in the sky. And right now it's the 25th, which is, come on, Betelgeuse. You can do better than this, right? We expect more from you. Top 25, that's that doesn't even compete now. Okay, so why do astronomers think that it's dimming?
Well, we have three competing reasons. The two likely ones are it possibly puffed a blast of dust our direction, and that dust is obscuring how we see the star. It's distorting the shape we see and essentially scattering light so that we see the entire star as dimmer. If
Right.
this is the case, we should eventually be able to figure this out by looking at enough spectra and seeing that the color as a function, the brightness of the cut. Start over that sentence. What we should be able to see is its brightness as a function of color changes in ways that are distinctive of warm dust instead of warm star. It won't be the black body that
Right.
we're used to.
And an
So we're looking
analogy
to see that.
an analogy that I think about is like, when you see the moon, like a full moon, but there's like part clouds and you can see, and the wind is moving really quickly, you can see these clouds just moving in front of the moon, like, and the moon is just changing in brightness and dimness as these clouds are moving past. And so imagine the moon was throwing out its own clouds. And that's what's
Right.
right. So there's one, just clouds of dust that it threw out recently or a long time ago that happened to be obscuring our perspective, and that will clear up. So what's one of the other ideas they're thinking of?
Well, the other is just like our own sun, Betelgeuse has convective cells. We talked about this last week in our episode. And these convective cells on Betelgeuse are much, much larger. And if you have the cooling flows of two different convective cells interacting in interesting ways, you can potentially end up with a big old cool spot that we're looking at that is going, hi, not generating as much light, gonna make the whole star look fainter here, people.
Yeah.
And so this could be an atmospheric effect where just changes in the churning of this roiling gas are giving us a cool perspective. Again, this is a
Literally.
thermodynamic effect.
Yeah.
Literally.
Literally a cool perspective. Yeah. And we, as you said, right, we talked about that last week with the pictures of the sun, and that you see those convective cells, those bright blobs of gas. And then you see the darker regions around it, and they're still incredibly, insanely hot. It's just that they are darker compared to the hot parts. And so, same thing, that you're getting less light in total, just based on the way you're seeing the star, the perspective. You happen to be getting the right combination of gigantic convective cells and then darker regions.
And just like sunspots on our own sun can be bigger in size than Earth, the sunspots on Betelgeuse, we think the biggest can be bigger than our sun.
Oh, way bigger. So I've heard they are 60%, they can be 60% the size of Betelgeuse. So
That is significantly bigger than our
yeah,
sun.
yeah. So like, the orbit from the from the sun to Mars, or I guess or from the sun to Jupiter, right? So imagine a sunspot that is hundreds of millions of kilometers across.
Yeah, that's big.
Yeah. And yeah, and I double checked that, and it's not 60% the size of the sun, it's 60% the size of that sun. Betelgeuse. Okay, so that's two reasons, right? You've got dust, you've got just like a happenstance of convective cells. And what? The third idea is just that it is in one of these expanding and contracting phases.
And the added step of that is that it's in one of the contracting phases, and as its surface area gets smaller, the amount of light we get, well, less. And maybe we just completely screwed up how old this star is. Maybe this star evolved off the main sequence much longer ago than we thought. Maybe we've misjudged when it had its first dredge up, and we don't fully understand the chemistry in the outskirts of a star. And maybe it actually is going to go boom.
Mm-hmm.
But very, very few people. It's basically we're hoping we're completely wrong because we want to see a
Right.
supernova.
Yeah.
Can we please be wrong?
And so let's talk about, I mean, obviously we know that it could explode at some point within the next 100,000 years or so, maybe the next million years or so. We could be the ones to witness it,
Yes.
but there's no reason to believe that this is that time.
No. Betelgeuse doesn't care what you or I want.
Right.
It just follows the rules of physics.
So why does dimming not tell us that it's about to turn into a supernova?
Because there's these other effects that can make it dim as
Right.
well.
And
And
there was an interesting post from Ethan Siegel. He was sort of talking about this, and the gist is just like it just takes time for things in the core of the star to reach the surface, thousands of years. And so, whatever we're seeing in the core, whatever is happening in the core, we won't know about it for thousands of years. Not just like the time it takes for the light to get from, but the time it takes for that radiation to actually make it through the material in the star. So whatever features you're seeing on the surface of the star right now aren't necessarily what's happening inside the star.
this is where looking at its long-term behavior matters so much. Uh, it was talked about by Ed Guinan back in December that this is an unusual low, but if it's just something having to do with its normal periodicity, it should start to re-brighten right about now.
Yep. And it kind of
And
looks like it has flatlined, right?
it doesn't just look like it's flatlined, but for the past 2 days, multiple observers' observations combined are showing that it just might be starting to re-brighten.
Right.
So instead of being that low of 35% its normal brightness, it's now crept its way up to being 39% of its normal brightness.
Right.
And so maybe it's starting to come back out. In which case the question becomes, what is the slope? And that starts to tell us what might be causing this effect. We're catching a star in the process of dying. Human society might actually even last long enough for us to document the entire thing. I mean, who knows?
Yeah.
Maybe you'll still be around in 100,000
In my
years and you're
in my robot bodies, yeah.
1,000. Yeah, yeah. But this is the first time we've gotten to document this.
Yeah.
This is a star 600 light years away. It's not that far away in the grand scheme of things. It's big enough we can see it as multiple pixels on a detector. We can see its sunspots. We can see right now using the very large telescope and its sphere instrument that the shape has changed. This is not the spherical star we saw a year ago. This is this weird distorted something that it may not be physically distorted, but the places where the light is coming out
yeah, and I think
are
that's
distorted.
important. Yeah, so I
Yeah.
had, it looked when you look at the pictures and you can see this sort of really bright blob at the top and this darker region down. It looks like the star is blobbing out, but it's almost certainly that it's just a region that is bright and shiny and a region that is less shiny, possibly
And
with that cloud, as I mentioned, passing in front of it, or but
and
it's
the
not
way to
actually.
think of this is a super dirty lampshade outside. I have some outdoor lampshades that dirt and grime and stuff have all gathered in the bottom of the light shade. And so when you look at the light, it's not this pretty sphere of light. It's this mottled grossness reminding me I need to clean lampshades.
Right.
Well, the dust and grime around Betelgeuse, the darkness from whatever convective cells may be merging, all of these different things can add up to what appears to be a non spherical star that's just spherical, but doesn't have a blob of dead bugs like my lamp, but
Right.
it's got a blob of dust.
Right. So I think, as we bring this episode home, it's an absolutely fascinating star. Wonderful that we have such an incredible red supergiant so close to us. Probably not going to explode in our lifetime, but
But I want it
of
to.
course we all do. Come on. And anyone who's worried about the Betelgeusians, they've only known suffering for the few short millions of years that this star has been around.
That's true.
That the explosion of this star would be really just icing on the cake of just a few short million years. Like, just imagine, right? Your star.
Our solar system hadn't even finished the Great Heavy Bombardment at the point in its history that is the same number of years as the Betelgeuse system has been around. It's a baby solar system.
Yeah. So, like, think about how long planets take to form. It's already died in that process. Not to mention, it is pumping out radiation at obnoxiously high levels. Not to mention, it changes in size from the size of the asteroid belt to the size of Jupiter. You try to live near a star that's changing. Like, there is nothing habitable around Betelgeuse. When that star goes,
we can see it.
We'll be able to see it. Well, but we'll keep you posted if anything does happen. Pamela, do you have any names for us this week?
I do, and I just want to once again thank all of you out there who support us month after month, and we're here thanks to you. Susie is able to do all the heavy lifting around here, and we can pay her because of your patronage, and we couldn't do this show without having her there to do all the heavy lifting. So I want to thank those people who really made this possible. And this week, I'm going to thank Michelle Cullen, Neuter Dude, William Lauer, Eric Farringer, Ryan James, Shannon Humber, Nelia, Kristen Brooks, Glenn McDavid, Dan Littman, Kaselia Panfilienko, Dean, Mathis Hendon, Benjamin Davies, Russell Pitto, Martin Dawson, Kamansky, Dana Nowry, Bart Flaherty, Father Prax, Andrew Stevenson, Kenneth Ryan, Dean McDaniel, Donald E. Mundus, and Antisaur.
Awesome. Thank you, everyone, for your continued support of what we do. You support us directly so that you can get your space news from us as opposed to relying on some traditional, old school media channel. I mean, I'm not saying it's aliens.
It's not aliens.
It's not aliens. All right. Thanks, Pamela. We'll see you in several weeks. So stay tuned when the next episode comes out when I'm back from Japan. Thanks, everybody.
Bye. Please tell me you're at least taking a recording setup.
This is not my trip, man.
Maybe. So my concern is I'm watching all of these countries doing you're no longer allowed to fly here from there.
Yeah.
And so I am less concerned about you getting the coronavirus than you ending up there and told you're not allowed to come home for some period of time.
Right. Sure. I will take my Zoom with me.
Okay.
I'll probably take my camera too, but they sell them there. So, that's where they all come from.
It's true.
Yeah.
And so they sell almost everywhere these little triangles that are a protein in the center, rice,
yeah,
and then this magical origamied seaweed where if you take off the wrapping just right, it comes off in a way that I'm going to go with magic. I don't understand this technology that allows the nice crispy seaweed to go from not touching the rice because that would make it damp and yucky to touching the rice, allowing you to eat this perfect triangle of tasty goodness.
Mm-hmm.
You need to eat at least one of these on my behalf.
I will. I'm stoked to eat one of those. All right, we got a few minutes to tackle some questions before we have to keep working on other projects.
It's true.
Aim Ellen Arch asks, if the core had just today stopped fusing, how long would it take for its outer layers to notice? Will all the material instantly collapse or just the inner layers?
No. So it literally takes photons billions of years to work their way out from the centers of stars.
Well, I've
It
heard,
won't take
I've heard,
billions of years.
I've
Go
heard.
ahead.
Oh, I've heard tens of thousands, not billions.
Yeah. Well, so the given random walk time for a given random photon,
Right.
quite long.
Can be billions, or it could be
Yeah.
a week. It's random.
Right. Yeah,
Yeah.
it's Brownian motion.
Yeah.
But for enough of them that we'll start to notice, you're looking at thousands of years.
And so you're getting like when that, like you're having those, it's burning, say, helium in the core, and then it switches to carbon, then it switches to neon, and it switches to silicon, and it switches to oxygen, and moves its way up the chain of elements until it hits iron. It stops instantly. The outward pressure instantly stops. Like that last shift over up to iron, it happens within minutes, right? And then the outer layers start to collapse in on itself. And by the end, I know it's moving at, say, 70% the speed of light. Like it's going really fast as it's all
Yeah.
coming in. But that moment from when the energy turns off in the middle to when the outer layers start to collapse in, that's thousands of years. Like, wonder what the delay is. Do you know for sure?
Well, so there's going to be thermodynamics trying to support it.
Yeah.
And so as this cloud is slowly infalling, the heat is going to push outwards the same way Jupiter is supported thermodynamically.
Right.
But eventually the collapse is going to overcome the thermodynamic outward push.
Right. Incredible.
Unbalanced forces.
Yeah, and that's the thing, right? Stars are perfectly balanced, and then suddenly the balance disappears, which is just incredible.
And what gets me is how thermodynamics works so hard to try and restabilize and just can't pull it off.
There's nothing left. Yeah.
No.
Let's see. So Rich 901 asks, does it have any planets?
Not that we've ever found.
No. And like I said, if it does, they're horrible places to live.
We're talking it's going to have like only the outermost parts left.
Yeah.
So like that planet 10 that Michael Brown is searching for, it could have that.
The half-blind astronomer is asking, will either of you be down at the Cape for DM2?
No,
No.
we're sorry.
Yeah, well, it's, you don't have to be sorry for not having the money to fly down to Cape Canaveral to watch a rocket launch.
Yeah.
It's an expensive process. I mean, we did the American Astronomical Society meeting. I'm not sure what your budget was, but we went absolute shoestring, right?
Yeah.
We bought our own groceries, me and Chad.
Yeah.
So it was,
That's mostly what Kyle and I did.
yeah, it was, the two of us flew. I booked a hotel on Hotwire that ended up being pretty great and had a kitchen, but it was, maybe a half-hour walk from the convention center.
Yeah.
Plus food, and like I said, we cooked as much as we could, and snuck food while we were at the conference. Probably cost me $4,000 to pay for the trip for the,
Yeah.
Plus
Yeah.
all the work that, plus the having to pay Chad the salary. So, like,
I didn't have to pay my husband the salary.
Yeah.
I do have to live with the ukulele he purchased.
yeah. So that's it. I mean, like our ability to report on space news is constrained by
Yeah.
our budgets.
Yeah.
And for me, I mean, you've got some funding that comes sometimes.
Yeah. Right now I
that
don't. I
comes
have in the
from-
past.
Yeah, that comes from various institutional organizations, and they fund your, they summon you to various conferences and events and things like that. But for me, it's literally like if I want to attend a rocket launch, or if I want to attend a conference, then I just do I want to not hire writers to write?
Right. And we have in the past been in really good positions with the help of all of you that we've been able to to fund ourselves through Astronomy Cast to go down and do this. Um, we have Susie doing a lot more
Mm-hmm.
nowadays,
Yeah.
and we used to have a student
Yeah.
instead.
Yeah.
Susie costs more than an undergrad,
Yeah.
and we love Susie,
Yeah.
and I'm happy to pay her more than
Yeah.
we paid an undergrad. But yeah, this is the real life.
Mm-hmm.
This is what we live with.
Yeah. And just imagine, right? Like imagine you have a job
Hmm.
and that job has interesting things that are happening around the world that you could participate in, but you would have to pay for them out of pocket.
Yeah.
You know, you'd be like, sorry.
Occasionally you
Yeah.
do.
Yeah. And so you save up and you
Yeah.
try to make the most of it. And the rest of the time you stay at home where it's inexpensive and you work your tail off trying to save up money for whatever thing you can do next. I mean,
But when you do it at home, you can have a dog on your feet.
sure. Yeah. But I think that's just the difference, right? Is that I
Yeah.
think that in the olden days, you know, if you were a space journalist and you worked for a media company like NBC or CNN or whatever, then they would fly you to a rocket launch and then you would cover the rocket launch and then you would fly back, and they were a multi-billion-dollar media organization, a multi-million-dollar media organization, and they could, and that was just the cost of doing business, right?
Yeah.
For me, if I attend one too many event, then my whole business goes under. So I have to I have to be super careful about it, which is funny. And James
Well,
Dugan is
to
saying not coming down for star stuff this year in Byron Bay. No, no. I mean, last
so
time,
to put some perspective on this, because I'm doing taxes right now,
yeah, me too.
the travel expenses I had to pay for last year out of pocket ate more than 10% of my income pre-taxes.
Hmm.
So
Yeah, yeah. And so we just don't. And the
yeah,
hope is, right? The hope is that, I mean, the plan has always been that what we are doing is the future of media.
yeah,
That we saw CNN and NBC and all these people have to lay off all of their journalists so that
yeah.
they couldn't do the work anymore. And so there now is nobody at any of these big agencies who on a regular basis does this work. That
But
it's,
I do have to say hats off to all the folks that have human beings tuning in to every press conference, attending
yeah,
everything they can. I look at like Spaceflight Now
yeah.
and oh man, I hate when I blank on names so completely. What's the name of the fellow that was at AAS with us?
Oh, there was Space
Foist.
News. Yeah, there's Jeff Faust, and there's
Jeff
of course the
Faust.
good, yeah, the
Yes.
people at Spaceflight Now and NASA Spaceflight are doing incredible jobs. A lot of the
Right.
times they live in Florida. You
Yes.
move to Cape Canaveral and then you drive onto the Cape and you cover the launch every
Yeah.
time there's a launch. And I think that's, you know, obviously as a Canadian, I'm limited in my options. I have to get escorted whenever I go anywhere near any flight hardware by armed guards. Um, Not by armed guards, just by people
Yeah.
who just keep
But still.
apologizing to me. So it's like a
But
huge
then you're
crowd.
Canadians, you just
Yeah, I
apologize
apologize
back.
back. Yeah, so whenever we go to the Cape, there's like a crowd of all of the Americans, and they all just get on buses and they drive around and they park and they say hi, you know, get coffee
Yeah.
and they walk over to the vehicle assembly building. And for me, I have to have a babysitter because I'm a foreigner, which is funny. But anyway, so that's it. So I think that it's just important for people to just
Yeah.
understand how this all works, right? You know, if what you're looking at through this camera is about 75% of my studio, of the entire Universe Today operations. Here, I'll change this camera screen. There, that is all of Universe Today. Everyone is watching right now. There's like a little bit above, and maybe a little bit this way, and then that's Universe Today. And
And this is my
and
universe unless I'm
yeah,
cuddled to a
yeah,
radiator. I
yeah,
do have to claim the
right,
downstairs wingback chair
yeah.
as part of what I do.
Yeah, yeah. And so, I mean, to the one credit, be, we get to do this job,
Yeah.
and we get to keep showing up every day and keep telling stories about space and do the work that we love. And the downside is that we are on our own, and
Yeah.
all of the risks that that entails. So it's a
It's
great time.
terrifying.
I wouldn't change it for anything. I'm unemployable. You could not, like I could never be hired just because I'm just too. I would just be insufferable as an employee. So no, I don't find it terrifying, but I also know that you just got to work within your means. And that's what we do.
Right.
So people always, I wish we could attend more rocket launches. I wish we could attend more events. I wish we could do higher production values. I wish we could hire more writers. All of that stuff would be
Your
wonderful.
production values on your Guide to the Universe series are as good as anything else out there.
And that's just us just practicing, tweaking, figuring it out, and still
What
constantly doing it on the cheap, right?
what happened to your copyright complaint where like the
Oh,
movie didn't know they'd use
yeah.
NASA? Explain this. I saw your tweet
Oh,
and I
sure.
was just like, oh my
Oh, well, this
goodness.
happening. Do you not get copyright violation stuff from YouTube ever?
I only on the music that we're using
Mm,
because we use David Joseph Wesley's music, but
okay.
we have his permission.
Yeah.
So yeah, we get those
Yeah,
constantly.
I get them all the time. And so in this case, there's a movie, and I'm not going to copyright shame them, but there's a movie company that that made a copyright claim on a video that we did, and when we actually dug into it, we had used the same footage, the same Creative Commons 4.0 footage from the European Southern Observatory. And so obviously we have permission to use the clip. So obviously
Yeah.
I counterclaimed on the copyright claim. And so now but as a claimant they get to just take all the revenue from your
Yeah.
video. And so now it's in escrow. And now it's up to them. They have to double down and go, no, 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 no. That Creative Commons footage that you used from the European Southern Observatory is ours. And we're going to take you to court, which they won't. So it just takes 30 days to run out the clock before their claim expires, and it gets automatically dropped by YouTube unless they decide to double down, which is ridiculous. So
Yeah.
I'm not super concerned about it, but I do find it kind of hilarious because my guess is whoever works at the movie company didn't realize that this sequence is
Was
just
not CGI'd
is
by them.
it's not CGI by them. Yeah, it's just a clip
Yeah.
that they used, and I'll bet you they didn't provide proper attribution to the European Southern Observatory in the way that we did and
Yep.
always do. So anyway, I find it hilarious. But this happens all the time, and a lot of times I'll get claimed from like news networks and stuff where there's a piece of NASA footage, and you just
Yeah.
roll with it because we are really careful about making sure that we don't that we respect all the copyrights that we run across and get
Yeah.
permission, and we'll even not use stuff if we have to, like
Yeah.
you will never see a clip from Star Trek or Star Wars or anything in anything we ever do, ever. Right.
Yeah.
In fact, we talk about aliens every now and then, like the movie Aliens or just aliens in general, and we have toys that we can show on screen because we're just I don't want the grief. It's not worth it. So anyway,
Yeah.
but yeah, thank you. I'm glad you're enjoying them, and we that's the downside is it just forges you into doing your job better. Like, don't you find
It's
that
true.
that all of the financial difficulties that you guys have gone through and all of the fundraising and all that has just made you better? You just have to be more resourceful, more
It
faster, right?
it that is true, but I have to admit the every single month do I have enough money to make payroll, which you've dealt with your entire
Hmm.
adult career.
Yeah,
I'm dealing with I'm used to having at least 3 months payroll on reserve.
yeah,
And I don't have that.
yeah,
All of our reserves went away. And
yeah, yeah. Welcome to my world. Yeah.
I don't like it.
Anyway, sorry for the digression, but I thought it was interesting. Like that's just the reality that we live in, and I think, and it's
Yeah.
definitely not a complaint because I wouldn't have it any other way. It's wonderful that we get a chance to be able to do this in the way that we do it and the way that we get to
Yeah.
work without any corporate overseers. But, it, as Ritual says down in the comment, it takes away energy from the other things that we do.
Yeah.
And it's, like there are advantages to being part of being a cog in a bigger machine, because you don't have to worry about all that stuff. You just show up at the administration desk and you pick up your tickets and you fly on your airplane to go to the launch, and then you file your story and you return back. So anyway, we should wrap up this episode. Like I said, there is a new episode of the Guide to Space all about the Artemis program coming in a couple of hours. As soon as that's ready, I will let you know, and I'll do a premiere with everybody. And until then, have a nice little break, Pamela.
I shall. I'm
See you
going
in a
to
couple
use it
weeks.
to catch up on writing.
Yes.
For those of you who haven't noticed, I've been posting articles up on Medium. Everything is linked to on my Twitter account. These are mostly taken from the Daily Space, and those that aren't are also appearing on Starstrider.
Yeah, Medium is starting to paywall stuff, so you might want to use a different place. I wouldn't use Medium anymore.
They pay.
Oh, okay. Well, then never mind. Do it. Fill your boots. Sorry, I thought you were using them for free. So
no.
Yeah. Okay. Great. Do it.
I will stop using them and produce everything for free if my Patreon does better, but not there yet.
Yeah. That's
yeah.
what I do. So, okay. All right. We're gonna wrap things up. Thanks, everyone, and we'll see you all next week.
Okay. See you later. Bye-bye. Do not get quarantined.
I promise I won't.